Greetings, Earthlings. Well, this you've seen before in a previous video. This is the 5304A Hewlett-Packard frequency counter. This is new to me. This is a multimeter. And you can see it's basically the same form factor. But it's a different series, 34703A. DC volt, DC amp, and ohm meter with a 3470A display. This was a 5300A measuring system display. So those displays, same concept of the pluggable, modules and display systems, but the displays are not interchangeable. This one is counter based. This one is voltage based. But same size factor and cuteness factor. So we're going to take a look at this. It's missing the tilt-up bail there, or whatever you call that thing, a little wire, which is why it's not tilted up. On the back, we have power, we have the voltage selection, and then there are some adjustments here. Some adjustments. Okay, and then these are the tabs for separating it, which we'll get to. But the first thing we want to do is just go ahead and plug it in and see what happens. It might blow up. Let me think. What did it say? The eBay listing said power's on. Okay, that was the only thing. It didn't say it was working. It didn't say it doesn't work. It just said power's on. Okay, so we've got on the volt setting, no power on, and okay. Well, it's got the same sort of cute display. And again, there are two different displays: the 7450 and the 7740 and the 750. This is the 740, which is 4.5 digit. The 750 is 5.5 digit. However, the basic accuracy of this meter is such that it's not a true 5.5 digit multimeter. So you could put a 750 display on it and get an extra digit, but it wouldn't be all that meaningful or useful if you care about accuracy. Okay, so 100 millivolts is showing about 50 millivolts. That's not too good. And let me give it 10 volts here. From the Fluke 343A. And, well, that's saying like 8.5 volts and bouncing around. So we got some problems here. It's making noise. I don't know if you can hear that. Sort of boogie-woogie sound. So we could have power supply problems. So the neat thing about this, they had several of them. There's 7402, and 34702A, 34703A. This has auto ranging. It does 4-wire resistance measurement, and actually only 4-wire resistance measurement on this one. So here's a resistor, 100 ohm resistor, with 4-wire leads. And they would connect this way. And switch. And what is it saying? Half a millivolt. About 100 ohms. Well, that's not horrible. Except it's bouncing around. So, again, there's some issues. But it's showing close to 100. So it's going to need a calibration, but it's going to need some repair as well. I don't have a manual for this right now. I have one on order. Okay, other interesting things about this. It has a 10 millivolt full scale range. It has a 1 ohm full scale range. So it goes from 1 ohm full scale to 10 megohms full scale. It has a 1 microamp full scale range, up to 100 milliamps. That's pretty darn good. There's some user information here. Input terminal connections, okay, whatever. Test function, oh, okay. So look, here it has test volts, ohms, and amps. So if I put it to test, what do we get? Set function range test, set range switch to manual. Press step button to increment test sequence. Oh wait, okay. Test number 1, 10 volt DC required at input. Okay, wait. Let's bring our 10 volts back. And test number 1, which is indicated there. So there's 1, 2, 3, 4, 5, 6, 7, 8. Okay. It has 8 tests in it. So on test number 1, it should be reading 1.0000, and it doesn't, so there's a problem. We switch to test number 2, and it should read 10.000, and it doesn't, and that's a problem. Switching to 3, it should read 0, and it doesn't, so there's a problem. Switching to 4, it should read all 0, and plus or minus 3 counts, and it doesn't, so that's a problem. Switching to 5, it should read 0, and it doesn't. So that's a problem. 6 should read 0, that's a problem. 7 should be 0, that's a problem. I don't know if it doesn't like the 10 volts. Let me short those inputs, see if that makes a difference. And 8 should be 0, okay. So we have a number of problems there. Now we switch to auto mode and run through it again, and this should say minus 0.1000, and it doesn't. Minus 10, no. Minus 10, minus 1, minus 1, minus 100, minus 100, and then logic test. Oh, okay. That was weird. It's supposed to take 4 seconds to go through that. And it steps up through and back down, and I don't think that worked either. So switch it off. Let's try. Let's separate these halves and see what we can see inside. I'm going to unplug it there. So, like with the other one, you pull on these, and that separates it. Separates the 2 halves. Okay. And looking here at the top part, the display unit, I see some burning of the PC board here. That could be an indication of something. I don't know. And well, most of the interesting stuff is on the other side of the board, so we'll have to pull the board out. But let's look at the other side, measurement side here. This looks a little, I don't know, crufty dusty. There's a socket there that doesn't have anything in it. I don't think that's a problem. I think that's a test socket. But the way the way this thing is set up, the first thing to do would be to get the display unit working on its own, and then proceed from there. There is a test card that will plug in here and you can use to help test it. It's not, they're very hard to find. Although I did see somebody made a reproduction and made that available on Oshpark, so I may have to get one of those. And so that will lift out. And we can see here what it looks like inside, or go this way if you prefer. Okay, we got some power supply capacitors. They could be bad, who knows. Date codes. I'm seeing what looks like a 73. Okay, there's a custom HP part. If that's bad, I'm hosed, because I'm sure there's no way to get a replacement for that other than to take it from another unit. There's TTL parts. I saw some TTL part numbers in here. A lot of them have HP part numbers on them, but there's a 74. What does that say? 7432. Yeah. 7432, 7408, and so on. That burn PC board, that's over here. That looks like it was a resistor at one time. We'll have to have a closer look at that. Anything else? The displays, of course, these sort of dot matrix LED displays, they work, as we saw, which is a good thing, because again, there's no replacing those if they go bad. Got a 3 megahertz crystal down here. This would be, we've looked at digital multimeters previously, and it's a dual slope conversion, and this would be the it's the display part, but it would have the integrator in it, and it takes as input like it takes an input voltage in a range of -2 to +2 volts and displays it. So what this plug-on piece does is it takes whatever input you're giving it and conditions it to that range of -2 to +2 volts. Okay, I hope that made sense, because my brain, or at least my mouth, isn't functioning all that well right now. So I don't see anything obviously bad here. There's suspect parts there. The power supply, I'm going to say, is suspect, because, it's from 1973. It's like 50 years old. And those are probably the original capacitors. So yeah, well, what I can do is like plug them back together here. And that provides access to the board here. There are some test points on this board, but again, I don't have the manual. So, well, wait, I probably can find an online manual for this part. It's just this one that I had to order. All right, I found an online manual for this top part, and it's got some of the points marked. +5 supply is there. Plus and minus 12 are, where are they? They're down here somewhere, right there. Plus and minus 1 volt reference are there. That's not all the power supply voltages, but it'll give us a start. So we'll look at look at it on the Keithley here, and orange should be +5, and yeah, 4.8. That's good enough. Let's go plus and minus 12. Minus 13.8 and plus 12.5. So the minus might be a little out of spec there. Let's look at these references. This is supposed to be +1 volt reference. That's pretty close. It's supposed to be the -1, and that's pretty close. Okay. I'm going to go again and look at the ripple. $30, 40 millivolts. 90 millivolts. See, now that one's good. 8 millivolts. Okay. That was on the +12. This is the -12, and it's showing 90 millivolts. So I'd say the -12 supply is suspect. I don't need to check it on those. The -12 supply is suspect, and the +5 is a little suspect. All right, I found a clue here. A clue. Interestingly, when it's plugged in but not powered on, the power supplies are still getting power. And that's, I think, because you can have a plug between these two that's a battery pack, and it needs to be able to charge the battery pack. So notice it's turned off, it's plugged in, and if I were to measure, say, the +5, we can see that it's still outputting +5. Okay, so, but here's the thing. Remember, I noticed that burned area on the PC board, okay? Well, I looked here, and that's the Zener diode for the -12 volt supply, okay? That's showing the burn. And if I look at that, there's like -16. The other side is ground. And so that should be like -13 volts. Because it's a 13 volt Zener. Or Zener, depending on where you come from. If we look at the +12 volt, that is this one here. And you see that is about 13 volts. So that Zener diode is bad for the -12 volt supply, and so the -12 volt supply is bad. So somewhere along the line, it got cooked. Okay, so it turns out I had some 13 volt Zener diodes. These are 1.3 watt, whereas the original is rated at 0.5 watt. So I put one in there. There's the old one I took out. It's dead. Replace that. Let me see it here. It's right there. And powered it up, and the -12 volt supply is still bad. and the new diode gets quite hot. And we saw from the burned board that the old diode was getting quite hot, to the point of melting away or whatever. So, looking at the schematic here, if you can see that, here's the minus 12 supply. And this tells me, so it gets hot because there's too much current flowing through it, okay? Where can that current come from? It can come through here, or it can come through here. It's not supposed to come through here, but I think it is. Most likely case is that that transistor is bad. How do I know that? Well, I measured the voltage across this resistor, and it shows that there's about 9 milliamps flowing through here. So it can't really, 9 milliamps is not enough to cook this. So apparently what's happening is that this transistor has a bad junction in it, and we've got current flowing from, the raw, whatever that is, minus 20 volts DC or whatever, right on down through here and to ground. So that transistor is a 2N4037. I don't have any of those on hand, but I can get some. And so that's what I'll do. And we'll pick it up from there in the next video.